Storage systems. Intermediate level. Understanding data storage. Introduction. Storage systems are responsible for saving and retrieving data in a computer. Unlike RAM, temporary memory, storage keeps data permanently, even when the system is powered off. Modern computers use different types of storage technologies, each with different speeds, different capacities, different use cases. At the intermediate level, understanding storage systems means learning how data is stored and accessed, differences between HDD, SSD, and NVMe, how storage interacts with CPU and memory, how performance affects system speed. What is a storage system? A storage system is a hardware component used to store data permanently. In simple terms, storage equals long-term memory of a computer. Example concept. Files means saved in storage, means loaded into RAM, means processed by CPU. Why storage systems are important. Every operation in a computer depends on storage. Example concept. OS plus apps plus files means stored in storage device. Storage effects. Boot time, application loading speed, file transfer speed, system responsiveness, types of storage systems. There are three main types: HDD, hard disk drive, SSD, solid-state drive, NVMe SSD, high-speed SSD. HDD, hard disk drive. What is HDD? HDD is a traditional storage device that uses spinning magnetic disks. How HDD works. Spinning disk plus read-write head means data stored magnetically. Characteristics: slower speed, large capacity, cheaper. Advantages: low cost, high storage capacity. Limitations: slow data access, mechanical parts, wear and tear, higher latency. SSD, solid-state drive. What is SSD? SSD uses flash memory, no moving parts. How SSD works. Flash memory chips means store data electronically. Characteristics: much faster than HDD, silent operation, more reliable. Advantages: faster boot and load times, low power consumption, durable. Limitations: higher cost than HDD, limited write cycles. NVMe SSD, high-speed storage. What is NVMe? NVMe is a high-speed SSD that uses PCIe interface. How NVMe works. NVMe SSD means PCIe means direct CPU communication. Characteristics: extremely fast, low latency, high bandwidth. Advantages: fastest storage type, ideal for gaming, AI, and heavy workloads. Limitations: more expensive, requires compatible motherboard. Storage comparison. Feature: HDD, SSD, NVMe. Speed: slow, fast, very fast. Low, medium, high durability. Low, high interface. SATA, PCIe. How storage works in the system. Data flows through multiple components. Storage means RAM means CPU. Storage means RAM means CPU. Step by step. Data stored in storage. OS loads data into RAM. CPU processes data. Results displayed. Storage interfaces. SATA used by HDD and SSD, slower than PCIe. PCIe NVMe, high-speed interface, direct connection to CPU. Example concept. SATA means slower, PCIe means faster file systems. Storage uses file systems to organize data. Examples: NTFS, FAT32, exFAT. Example concept. Files means organized using file system storage performance factors. Performance depends on read speed, write speed, latency, interface type, storage technology. Example concept. Faster storage means faster system performance. Real-world example. Opening a game. Game stored in SSD, loaded into RAM, CPU processes, GPU renders, displayed on screen. If storage is slow, programs load slowly. System feels laggy. Boot time increases. Example concept. Slow HDD means system delay. Advantages of modern storage systems. Advantages include faster access speeds, improved reliability, better multitasking, reduced load times. Example concept. NVMe SSD means high-performance system limitations. Challenges include Cost of high-speed storage, compatibility issues, limited lifespan, SSD writes. Example concept. Faster storage means higher cost concepts learned. Types of storage systems. HDD versus SSD versus NVMe. How data flows in a system. Storage interfaces. Performance factors. Simple definition. Storage systems. Hardware components that store data permanently and supply it to the system when needed. Final summary. Storage systems are essential for saving and retrieving data in a computer. HDDs provide large and affordable storage. SSDs offer faster performance, and NVMe drives deliver the highest speeds using PCIe. Data flows from storage to RAM and then to the CPU for processing. Understanding storage systems helps explain system performance, boot speed, and application responsiveness.